is Hanan from Amman, Jordan. It's a slightly different application in environmental, I would call it, but using similar techniques.
Bismillahirrahmanirrahim. Assalamu alaikum. Good afternoon. Hi everybody. I am very glad to be here with you, and for me it's a very exciting moment. Even before I introduce myself, I should say why it's a very exciting moment. First of all, because it's my first participation in ECAART. It's ECAART14, but for me it's #1. Second, because it's my first time in Romania, and I'm glad for that. And third, because this is my first in-person oral presentation after the pandemic. My last oral presentation in person was in December 2019. At that time, COVID started in China and it was not announced as a pandemic. And since then, I had many oral and poster presentations remotely, but then I felt fed up. So since months, I decided if it's not in person, I will not join. So it's exciting that this is the first oral presentation in person after the pandemic. Honestly, it looks like it's my first presentation in life. It's a long time, 2 years and some months without oral presentation in person. And because of all this excitement, it gives me back in my memory to one of my good memories. Back in 2009, when I was still a PhD student, I will give you a few seconds to look at this picture. Probably you will find yourself or you recognize other colleagues. I have a story about it. I will share it with you at the end of the presentation, if I have time, in order to keep the chair of the session happy. And now I can introduce myself. My name is Hanan. I come from Jordan. In principle, I am atomic and molecular physicist, experimentalist, using accelerator-based techniques. I am kind of atomic molecular physicist who is mainly doing basic science. But what I'm presenting today is more practical science, or more in applicational side. I have been working at the University of Jordan as a university professor since 2013. And since almost 7 years, I have been a frequent collaborator with the Electra Light Source funded by Abdussalam International Center for Theoretical Physics, ICTP. But again, what I'm presenting today is not related to my basic research. Because I'm the only Jordanian in the participants, I would like to show you the region where I come from. I am Jordanian Palestinian. And if you look here, here is the Arab countries in Asia. So here is Jordan. And if you have never been in Jordan, I give you this cocktail picture that is showing what is Jordan most famous about is Petra. You can see Petra in the right corner. But I put it in the right corner just to say, yes, Jordan is most famous about Petra. But it's not the only magical place in Petra, in Jordan. So there are many, many historical and magical places in Jordan that worth a visit. And I live in the capital, in Amman, and in the heart of Amman is my beloved university, the University of Jordan, where I studied all my education there, and where currently I am a researcher and a university professor. And the University of Jordan also hosts the only Ion Beam facility in Jordan, which is called JOVAC. This is the octagonal building, is the JOVAC facility. And JOVAC stands for the University of Jordan Van de Graaff Accelerator. And by the way, it's an accelerator manufactured by High Voltage Engineering since 1980. But the work that I will be presenting today was not analyzed at JOVAC. So the results are not analyzed at JOVAC, but analyzed using two other accelerators in Europe, particularly in Italy. However, if you ask me about JOVAC, I will be more than happy to tell you the story of JOVAC, because it's very dear to my heart, and it's the place where I was born as a scientist. I got my PhD at JOVAC, and I'm still doing research whenever I manage at JOVAC. So please feel free to ask me questions during the coffee break, during the lunchtime, wherever you meet me about JOVAC. I would love to give you the story of JOVAC. And even I would be happier if you manage to visit us. This was the last group of scientists that I hosted before the pandemic in 2019. So that's why I am very happy. I'm not used to such big smile, but that was the answer. And now back to the presentation, let's talk science. So I will tell you about the quantification and speciation of lead in air particulate matter. I know that all the speakers in this session were presenting some artwork and archaeological samples, so it would be challenging for me to tell you a story about air pollution. So I will tell you about air pollution. Thanks for the chair, because he gave me a push-up in the lunch. He said, but I am interested in air pollution. Okay, so I will tell you an interesting story about how to monitor and analyze air pollution in Jordan using two accelerator-based techniques, BICSI and XANS. And in this study, I am particularly interested in one of the harmful traces that have been found in Amman atmosphere, which is lead, unfortunately. And this work is a collaboration between my university in Jordan and two accelerators in Italy, one in Florence, which is the LABIC laboratory in INFM, and the other is Electra Light Source in Trieste. And I would like to say, without the support that I got through the ICTB for supporting the beam times at Electra, and through the IAEA for the support and the collaboration with LABIC, this work would not be possible. Now, briefly, I will introduce you about the objective of this research study, what motivated us to go in that direction, what samples have been collected and where was the sampling site, what experiments, mainly I said BICSI and XANS, and I will show some examples of the very first results, and finally I will sum up and I will give some visions toward the future. Now, the purpose of this study is very clear from the title, is the quantification and speciation of lead in air particulate matter, or you can call it aerosol samples, or samples collected from the atmosphere. So our goal is to identify whether we have lead or not, and if we have it with which concentration, and moreover to see what kind of chemical structure that this lead has in Amman atmosphere. And what was the motivation behind this study? I mean, what put me on that track to do BICSI and XANS for environmental samples? To be honest, what put me on that track is the lack of funds. And because when I joined the university, I was not sponsored by any financial means from the university. I found only the fund through the IAEA, and you know the IAEA priorities for sustainable development. One of the priorities is monitoring the air pollution. So I found myself the national leader for a regional project with the IAEA in Arasia. Arasia means Arab countries of Asia. So when I found myself leading this project, it's a regional project, so it's nice to do collaboration with several countries, though they are all in the region, they are all Arab countries in Asia, but also there is a sort of fund from the IAEA. The goal of that project was mainly to monitor the air quality in the region. So every country collects samples in a selected sampling site, and then we do harmonized sampling and analysis, and we compare the results, and we do mapping of the database that we obtain about aerosol samples. To do so, we need to do elemental, or to identify the elemental content, and this is as a primary goal. And as a secondary goal, we were also looking to understand or estimate what is the chemical structure. So our goal was to study the physics and chemistry of air pollutants in Eurasia region. But to be honest, when I started work on that, I loved what I'm doing. So because it's fairly easier to talk about an application inside of scientific research, especially for students, because I'm teaching at the university, so I found it much easier to tell the students how to analyze the result samples rather than to introduce them to Zeeman effect or Stark effect or whatever in atomic and molecular physics. So it was interesting, and I also started to supervise some research project for the students, and this was a master thesis that I supervised for my master student, Sarah Abu Ruqayya, and we did Pixie characterization for fine particulate matter, particularly emitted from a construction work that was held close to the sampling site at the University of Jordan. So we collected samples before the construction work and during the construction work, and we tried to see what impact to the air quality was made by the construction activity. And we published the results obtained not long ago in the X-ray spectrometry journal, and I can highlight what results that motivated me to do further investigation, not on all elements in the fine particulate matter, but particularly in one harmful element, which is lead. So the first result that we found, that we detected more than or about 23 elements in Amman atmosphere. Among those elements, there were some harmful elements, and the notable harmful traces were from lead. Surprisingly, we found that the concentration of lead decreased during construction work compared to its concentration before construction. So lead is harmful. It exists before and during construction in Amman atmosphere, but the concentration dramatically decreased during construction work. And because lead is harmful and it's considered carcinogenic, even if it's found in traces amount, I think it was to be studied. Now, what samples and where sampling were performed? The sampling site was in my university, the University of Jordan. Yes, I care about it and I love it, but it's not the reason why we selected it as the sampling site. The main reason is that it's an urban background, an urban area. So it's not an industrial factor, it's not a hotspot of traffic, let's say. So it's urban, where people used to go and come and work and live, and it's a bit far from traffic. And another reason, it's accessible for me. So I have the keys, I can change the sample during holidays, during, let's say, weekend. So these reasons were the reason behind choosing the university as the sampling site. And this is an actual view of the sample site. This is the rooftop of my office in the physics building at the University of Jordan, where you can see we collected samples using two samplers. And these two samplers, thanks again to the IAEA, they were purchased through the Eurasia project. And one of them is called ISAP. We used it to collect the fine particulate matter, BM2.5, and the other one is Sveglekel. And this is a picture of how the samples look like. The samples were collected in two fractions, fine and coarse. Fine particulate matter and coarse particulate matter depending on the aerodynamic diameter of the collected particles. And the sample was collected on thin Teflon filters and then sent for analysis. Now, what kind of analysis was performed? We did Pixie and we did exams, and each sample was cut into two halves. You saw that the sample is a circular disc, so we cut every sample into two halves, and we sent half of the samples to Labek to perform Pixie, and the probe was proton beam, and the experiment was done in external beam, or let's say in air or in helium atmosphere. And the other half was sent to Electra, and the probe was X-ray or synchrotron radiation. And it was done in vacuum. And here is an actual view for the sample holder. This is the sample wheel in Lübeck. It can host 56 half sample, and it took me about an hour, almost an hour, to analyze them all. And of course, it moves from one sample to another automatically through a software governed manipulator. And this is the sample holder at XRF beamline in Electra. It can host only 4 half samples, and it's under vacuum. So imagine each sample takes several hours to do XANs, and after 4 samples you need to switch off the vacuum and build up the vacuum again, so it's time consuming. So I managed to analyze hundreds of samples in Lübeck by Pixie, but only a few in Electra. I will jump the basics of Pixie and XANs because they are well-known techniques, but I would say these are the experimental parameters of performing Pixie at Lübeck. They have state-of-the-art detection system, 3 detectors, 3 silicon drift detectors, small detectors, small active area for detecting low-energy X-rays, and twin detectors, 2 detectors for bigger area for detecting the high-energy X-rays, and this is an actual view. About XANs, it was done at Electra, at XRF beamline, and the chamber there, they still call it IAEA chamber because it was built by a fund from IAEA, and here are the main experimental parameters to perform the XANs measurement. Why we did Pixie and XANs? They are both accelerator-based techniques. They are both non-destructive techniques, but this is not the main clue. The main clue behind using them that Pixie is well-known and very powerful and reliable in quantification. But it gives no information about the chemical structure. Now here's the role of XANs. It fills this gap. It gives you information about the oxidation states, which gives you reliable information about the chemical structure. By combining these 2 kinds of information, I believe that we improved our understanding of air pollution in Amman atmosphere. And as an example of the obtained results, these are the nice spectrum from Pixie. This is from small detector. We managed to detect from sodium up to iron. And this is the spectrum, the sum of the spectrum of the 2 big silicon drift detectors, where you can see there is a non-negligible amount of lead existing in Amman atmosphere. And regarding the XANs results, this is an example for the fine particulate matter. The black zigzagging lines is the raw data. I could smooth it, by the way, but I prefer to show you the very raw data. And the pink one is the linear combination effect of 2 reference lead compounds. I compared the data with different lead compounds to see what oxidation state or what chemical compound of lead is potentially present in Amman's atmosphere. I found that it's a combination, most likely a combination of 2 divalent lead compounds, which are lead sulfate and lead sulfides. To sum up, if I have time, I would like to say that Pixie confirmed, unfortunately, there is non-negligible emission of lead into Amman atmosphere. XANs confirmed that most likely the chemical structure of those lead in Amman atmosphere comes from divalent lead compounds, and by this information, XANs proved its feasibility to check the oxidation state of Jordan samples, although the load of the sample in terms of lead is very low. It's a trace element, but it was sensitive enough to do it. And if we do the measurement for much longer time, I believe that statistics will be further improved. And looking toward the future, I would say I have still much to do. I need to look at the data and to reanalyze it. Hopefully, if I manage to finish it, you will see it in the forthcoming proceeding. But also, I have other good news, happy to share it with you, that I got recently acceptance for another beam time at Electra. It's fantastic to get a beam time, because the time at the synchrotron you pay nothing, but it's really priceless that they give you a beam time. And the other good news that I also got acceptance through translational access of Radiate project at Lubbock. So still I have room to analyze more and more samples by Bixi and Xens in the very near future. Allow me to do the acknowledgement. So in terms of acknowledgement, I'm very grateful for all those institutes shown in the figure. I am very grateful to my university for the moral support, and also for a 1-year leave, teaching-free year leave to start, inshallah, next September. I got the approval verbally, and I'm awaiting the decision soon, so please wish me luck. And grateful also to ICTB and IAEA. In particular, IAEA funded me to join you this conference, so thanks again to the IAEA. I no words can say how much I enjoyed the work with my collaborating friends, Massimo Chiari from Lubbock, Simone Polastri and Giuliana Aquillanti from Electra, and last but not least, thanks a lot for the organizers to hold this event, and thanks very much to make it in person. And I would like to thank you for the tangible touch that you put in the conference bag. Actually, during the last 3 years, we missed the sense that you touch the abstract book, and also you find some souvenirs from the city that you are visiting for a conference. So thank you very much for this tangible touch that I believe that makes everybody happy. And in particular, I should also thank my dear friend Roxana, because honestly, she was the one who pushed me to come. And also, when I checked the first time, I found the conference without a sponsorship from IAEA, so I said, okay, I will not go. I cannot go. My university will not support me to go for a conference, especially after COVID. Now you can do it hybrid, you can do it remotely. So I said I will not go. But when the IAEA grant was announced, at that time I gave up, I got a message from Roxana that look, the IAEA will sponsor the conference. So thanks again for having you as a good friend. A good friend is a friend that invites you to a conference in his country or her country. Back to this. Now this picture is very dear to my heart. It was in 2009 in Trieste. In the background, please ignore this lamp. In the background is the Adriatic Sea. But it was cloudy February in 2009. For me, it's very dear to my heart. I was at that moment still a PhD student. It was my first participation in an international event. It was my first visit to Italy. It was my first trip to Europe. And in that visit, or from that picture, when I look at it nowadays, of course, why this conference reminded me of this? Because it was the first time I met Roxana. You can recognize maybe our faces here. So it was the first time we met in 2009. And of course, we met afterwards in many accelerator-based conferences. But I still remember the last day when we touched each other, that we said, okay, see you in the next future. As Roxana always said, you never know when and where. And I said, probably in Romania. And look, it took 13 years, then I'm here in Romania, and I came because of her message. So, the lesson learned, there are many lessons can be learned from this photo. I would highlight two, especially for myself and for the students, because I see many students in this conference. First of all, if you are young or if you are short, always go in the front line in the photo. And you can see me in the front line, and also if you check the ECAART conference group photo, you will find me in the front line, because I am still short and I'm still young, okay? And if you are tall or senior, now if you are senior, even if you are short, you go to the back line. So you can see Kukuris, he's here. Although he was young.
Really?
But he was the lecturer. He was the one who was training us for IBA. So he was in the back line. You can see Chris Jennis. You can see Primož. He's still tall. So he always in the back line. You see? And so this is a lesson. And the other lesson, when let's take it away message and then I finish. If you attend a conference, do well in your physics, do science that can be the messenger of you to the conference, but when you go there, don't only enjoy the atmosphere, the place, the food. Make sure that you make friends. Don't go home until you make friends, because you don't know, the friend of yesterday could be your host today. That's all, and thank you very much.
Thank you very much, Hanan. That was very, very lively indeed.
You didn't recognize
I'm still short now. When I learned the lesson in this ECAART picture, I was in the front. I was in the right place. Okay, we're out of time, so maybe we have time for only one question. Otherwise, we'll be interested in this presentation.
I'm here till the end of the conference. You can ask me many questions now and afterwards.
Now, no, Hanan.
Okay.
If there's one question, otherwise in the coffee break, because you have two more presentations by our sponsors. So, okay, so thank you again, Hanan.
Welcome.